Welcome to the first webinar in this series. Today, my colleague Max Guild will talk through how to get started with simulation. So without further ado, I'll pass you over to Max.
Thank you, Glenn. So within this webinar, we're going to take a look at getting started with simulation. So a little bit about myself. My name is Max Guild. I come from a maths background and I started working in process improvement in the banking and finance industry, where I got my Green Belt Lean Six Sigma certification. I now work as a business consultant at Simulate, so that basically means that I help to train people in how to use our. I also build models for our clients as part of our consultancy service, and I also work with our clients to work on projects, guide them through projects, and share my knowledge with them as part of our coaching service. Within this session, we're going to take a look at the benefits of simulation and some simulate basics. And we're going to start building a simple model of a car manufacturing plant. We're also going to take a look at some distributions and some routing. But don't worry if you don't know what they mean at the moment. By the end of the session, that will all be much more clear. As we mentioned, this is a series of webinars, and we're going to be using the webinars to add complexity to our model as part of the second session. And in the third session, we are going to be looking at controlling our simulation using a spreadsheet and adding some staff to that model. In session 4, we're going to be using a feature called Visual Logic to help us create a custom report. So a little bit about the benefits of simulation. Simulation makes it really easy for us to include variability within our model or within our system. So if we talk about having, let's say, 20 customers within our system every day, the chances are we probably have a bit of variation around that. So we may have 15 customers one day and 25 customers another day. We need to ensure that variability is taken into account in order that we can take account of good days, bad days, as well as average days. We can also use simulation to model interconnectedness very easily. So, for example, if we had a couple of runways at an airport which intersected, we can set that up easily within Simulate to model the behavior of planes arriving and departing. We can also include a lot of complexity within our simulation, so we may have different products or different people moving through different routes through the simulation. That can all be easily included within the simulation. What are the benefits of simulation versus real life? First and foremost is probably cost. So we work with our clients to basically justify whether or not they should include or within their manufacturing line. Sometimes these machines can cost millions of dollars, so they need to make sure that that decision is correct. So we'll work with our clients to build a model of their existing system, and then we can add that machine in to make sure that the benefits are justifying their investment. We can also analyze our system over a long period of time. So we've had client models that run for 400 years. That's obviously at the more extreme end of the scale, but our software is capable of handling that amount of time. We can also control our experimental conditions, which basically means that we can perform our what-if analysis. So for example, we might want to increase the demand on the system to make sure that we can still process that amount of work. We can also model systems that don't yet exist. So for example, we've worked with clients who are looking to test a setup of a new factory which is going to be installed. We'll work with them to build a model to make sure that that factory is as efficient as it can be, and it helps them justify their layout. So why do we use Simulate? So Simulate is a really useful tool for helping us to visualize our process. So particularly in presentation environments, we can show parts moving through the system, and queues will start to build up, and that really helps our stakeholders understand the process. Because they can start to see queues building up, they start to ask questions like, why is that happening? What's happening in that section there? And that really increases their engagement, and therefore is more effective than handing them a 50-page Excel report that only gets half read. If we can get them into a room for as little as 10 minutes, we can talk them through their process much more easily. All of that helps us to build better solutions. Those solutions should be much more robust, for example, because we've included variability. So we're taking into account good days as well as bad days, as well as other sort of more average days. The decisions that we make are much better supported because we're using our own data within the model. So really, our solutions should all be much more successful. Simulate is what we call a discrete event simulation software, and that basically means that we only model time when there's something happening. And when there's something happening, we call that an event. So that may be a piece of work arriving within the system or moving on to the next stage within the process. As a result of that, we will see that the simulation clock will jump between intervals. So it doesn't move around smoothly like a traditional clock. It only models time when there's something happening. We're one of the fastest discrete event simulation tools on the market, and that's verified as part of an independent test. Obviously, if there's more events, then the simulation will run a little slower. But when I'm talking slower, I really mean just a couple of seconds. Generally, if any of our models are taking more than 5 minutes to run, we would start to look at ways to make them a bit more efficient in their running. So we've had client models, for example, which have taken 3.5 hours to run. We worked with one of our clients to reduce that run time to 10 seconds as part of one of their coaching sessions. So there's usually a much better way of doing things. In terms of our support resources, just before we get into the software itself, we offer a lot of support for our users. We can use the F1 key or the help menu to access the help files, and that will give you specific information on how to use each feature. We also have the online user forum, which is called the Simulate Cafe, and that's where you can basically ask questions to the wider Simulate community, and they will help you out with any modeling queries. We have the Simulation Assistant within the software, and that basically acts as a prompt for any potential issues with your model. So potentially you might not have some activities which are connected to anything. The Simulate Assistant will do its best to point those out for you. We also have the support@simulate.com email address. The guys in the support team provide a really world-class service in terms of helping you complete your model or helping you out with any modeling issues you might have. They won't actually build the model for you, obviously, but they'll do a really good service in terms of helping you out with your modeling issues. We also have the Simulate website. If I click on the support link here, we have a whole host of different resources available to our users. We've got the knowledge base. There's all sorts of videos and tutorials within that. We've got some FAQs, which again contains more demos, and we've also got the help files. So there's a lot of support available for our users. So if I jump into the software now, we're going to take a look at actually getting started within Simulate. So for those of you who haven't seen Simulate, this is our software. This main area here is where we actually build our simulations. Up in the top left-hand corner here, we have our simulation controls, and we'll see them in use shortly. Along the top, we have a whole host of different tabs, all with different features available for us to help us build our models. Obviously, we're not going to cover all of them over the course of the webinars, but I'll do my best to cover as many as I can. Down the left-hand side here, we have our standard building blocks, which we use to actually build our simulations. Before we get started, I'm just going to double-click on my clock to open up my clock properties. And this is where we specify the timing properties of our simulation. Up in the top section here, we have our time units, and it's always worthwhile before we start building our model to actually think about which time units we might want to use. This is generally driven by the timing of our activities. So if our timing is measured in seconds, then we probably want to add our or make our time units in seconds for our simulation. If we're modeling things like, let's say, hospitals being built, the chances are our activities are going to take days, so we're going to choose the day option. I'm going to leave this in minutes for my example. Within the time format section, this is really just for personal preference, where we can choose digital clock faces versus traditional clock faces. And in this lower section here, this is where we can specify the number of days which we have, or which our factory is going to run. So I'm going to make this a 7-day week, and in this section here, we can specify the time for the day. So for example, if I wanted to model a 24-hour system, I would make this start at midnight and run for 24 hours. For my particular example, I'm going to start my day at 6 AM and it's going to run for 12 hours till 6 at night. We can also specify our results collection period. I'm going to change this to 2 weeks. Equally, we could change this to 400 years if we wanted. So I'm going to click on OK and OK. So we've set the time properties for our simulation. We can now start to actually build our process. So for building the process, it's always much better if you have a process expert or a process owner in the room with you and use their knowledge to help you build the simulation. It goes without saying that if your process more accurately represents real life within your simulation, you're going to get a better result. So to start with, we're going to add a start point. To add a start point, I just select the start point and I can click on screen. And we've added our first object onto the simulation window. If I select the start point, we open up this menu here, which is called the contextual menu, and that basically allows me to set any properties of the object. So I can change the name of the start point, I can change the timing. For a start point, this tells me how often, or the amount of time between work arriving in the system. From a start point, we want to add a queue, because we never want to connect active objects to other active objects. I'll come on to active objects in a bit more detail shortly. If I click on the queue, you can see that we can specify different properties of the queue. So for example, we can specify a capacity if we have limited storage space. specify a shelf life. For example, if we were modeling a supermarket, we might want to have some of our goods go out of date, in which case they would take a different route through the simulation. We can also specify a minimum wait time, which can help us model things like a drying process within our simulation. After a queue, or after the queue, I'm then going to add the first step of my process. And if I was speaking to the process owner or the process expert, they might tell me that the first activity is a bodywork activity. As I say, we're modeling a simple representation of a car plant. So the first step is going to be a bodywork activity. If I select the activity, you can see that we have quite a number of options here. These are really the most powerful building blocks within Simulate. They're able to pull work out of queues and push work onto other queues. The activity is what we call an active object because it can pull work or push work. A start point is also an active object because it pushes work into the system. A queue is a passive object because it waits for work to either be pushed to it or pulled from it. And when we're building our simulations, we always want to separate active objects with passive objects. So after the bodywork activity, I would ask the process owner, what is your next process step? They might tell me that it is the assembly process. You can see that I'm using quite a useful feature within Simulate, and that's the paddle to add the objects on screen. So the paddle works by selecting the object, and you can see these faint grey arrows. With the arrows, I can then select the next object that I want to build. If I don't move my cursor, you can see that I can quickly add a queue and then an activity. The third activity, let's say that's going to be an inspection station. At the inspection station, we will have some cars which pass inspection, in which case they're going to move on to the next queue. Other cars are going to fail that inspection. So for this example, I'm going to keep things simple, and I'm going to say that any cars which fail inspection are going to be routed to what we call an endpoint. An endpoint is a passive object. It waits for work to get pushed onto or into it, and it's basically used to keep the simulation running smoothly. It just removes any work items from the simulation in order to limit the amount of space in memory that we're using. At inspection 1, we now have a choice of how work leaves the activity. So we want to click on our routing out feature. By clicking on routing out, we're able to control or set up different rules for how work leaves the activity. You can see by default, if I hover over the circulate discipline, this is going to share work items out like cards being dealt from a pack. That means that the first work item is going to go to the first queue, then the second to the second queue, and then it's going to continue to alternate between those queues. That doesn't really represent what I'm looking to achieve with my model. So the process that, or the discipline that I'm looking to use is this percentage-based routing. If I select percentage-based routing, I can specify what percentage of work items are going to go to the first queue and which percentage are going to go to the endpoint to represent my fails. By using a percentage-based routing, we're effectively flipping a coin and deciding whether or not the car passes or fails. It's a completely random order, so we don't have any control over that, which more accurately represents real life. If we knew which cars were going to fail, we'd make the changes so that they wouldn't fail. There's another few routing out options here, particularly labels. We'll cover them in more detail in the second webinar, where we look at routing different products through different areas of the simulation. For the moment, I'm going to leave my routing percentage at 50% to each queue. So I'm not sure that I would last very long as a factory manager in this job if 50% of my cars are being scrapped, but this is just purely for example purposes. After inspection 1, we're going to go to a paint activity, and then we're going to have a second inspection. Again, because this is an inspection station, we're going to have some pieces of work which pass the inspection and others which fail the inspection. So we're going to have a yield at this station. Again, I can use my routing out discipline to let me choose which percentage are going to pass and which are going to fail. In this case, I'm going to say that we have 75% pass and 25% fail. For this section, we're going to include a rework loop. So rather than just routing to an endpoint, we're going to route our work back into the main assembly line. So they're going to pass through this activity here, and this activity is going to be a sanding activity. After the sanding activity, we have a couple of choices of how we might want to model our system. We can go to another queue and route into our paint activity. This will allow us to prioritize work items which come from the sanding station. To do that, I can select my paint activity and click on routing in. The routing in dialog is very similar to our routing out dialog, but the disciplines are slightly different. Many of them are very self-explanatory. So for example, the youngest will be, we will route in the piece of work which has been waiting the least amount of time. The one that I'm more interested in at the moment is our priority routing. So if I wanted to route in cars from the sanding station as a priority, I would move that queue to the top of the list, and Simulate will pull in from that queue before it will pull in from the queue before paint. That allows us a lot of flexibility, and we can use that as part of our experimentation phase when we come to testing potential improvements to our simulation. For the time being, perhaps we don't have space for a second queue of cars, so I'm just going to route this directly back into the queue for paint. I can add a corner to my routing arrow to keep things neat and tidy just by clicking on the routing arrow and dragging it across. After inspection 2, we're going to have a shipping activity. And then after shipping, we're just going to route to an endpoint because the cars have then left the simulation and they're outside of the scope of this example. So once we have built our simulation, we're then in a position to actually run the simulation. So let's click on our Home tab, and I want to reset my simulation before I run. And then I'm going to turn down the speed just using the speed bar here, and I'm going to click on Run. You can hopefully see some red work items moving through the simulation. The little red dots, or our work items, are really representing the cars which are moving through this process. In our example, they're cars, but in other simulations, there may be people moving through a hospital or calls moving through a call center. We can change the graphics of the red dots to make it much more context relevant, and add a lot more realism to our simulations. For the time being, we're just going to leave them as red dots. As you can see, the queues are building up and lowering as work gets added and removed from the queue. And you can see that we have numbers above each of the objects on screen. So at the moment, at my start point, you can see that 6 cars have failed. If I speed up my simulation all the way to the top, we stop seeing any animation because we're only focused on the result. And we can see that we have produced 494 cars over the course of these 2 weeks. It's at this point that I would want to speak to the process owners and the process experts and ask them, does this feel like a good set of numbers? Does this accurately represent real life? The chances are, at this stage, it probably won't represent a real life process. The reason for that is we've just used the default timings for all of the activities. So at the moment, all of our activities are taking 10 minutes. And that's not likely to be accurate or representative of the real life process. So in order for us to update the timings, we want to use something called distributions. And distributions are nothing to be scared of, but if you've not heard of them, it's worthwhile spending just a little bit of time talking you through what they actually do. So within the image we see here, we can see variability in action. All of these planes are taking off. So let's say each plane is a work item and the activity that they're currently performing is taking off. You can see that there's a lot of variation around the height of takeoff. And for example, this little plane here, just under the distributions and variability, it's taking off at quite a high angle, so we might consider that an outlier. By using distributions and variability, we're able to take into account these outliers and see the effects that they have on the process. We include variability within our simulation by using distributions. And if we were to gather all of our data points, maybe using like a stopwatch exercise, and plot those time points, they would have a shape. The shape is what we model with distributions. So in this uniform distribution, you can see that we can choose any value between 10 and 20. On the y-axis, we basically define the percentage chance or the likelihood of choosing a certain value. So you can see that because we have a flat top to this distribution, we've got an even chance of choosing any number between 10 and 20. We can also have a normal distribution, and you can see that around the extremities of this distribution, we have a much lower chance of choosing any of these values. We've got a much higher chance of choosing a value of around 10. With a normal distribution, we can also talk about standard deviation, which is basically how flat or how steep that curve is. And that's very important when we're using Lean Six Sigma, for example. When we have a steeper curve, that means the process is much more in control, and we can actually test what the benefits of our any process improvement we might do will be by using the simulation. So we might want to lower the standard deviation, and that might actually have a knock-on effect further down the process, and it might overload one of the other activities and cause a new bottleneck. So simulation really allows us to see the knock-on effects of process improvements in one area, which is an incredibly useful thing for us to see. The final distribution I'm going to show you is a triangular distribution, and this is a really useful way of summarizing our data, particularly if we don't have time to do any real data gathering. We can ask people on the shop floor what their best case situation is for processing a part at their activity, and they might tell us 5 minutes. which gives us our lower point. We might say, what's your worst case scenario if something maybe goes wrong, or if it's a particularly difficult part? They might say 50 minutes. And then we would say, what is your most likely time for processing? And they might say around 18 minutes. So that's how we build our triangular distribution. And this is a really powerful way of summarizing our data really quickly. So I'm going to add a couple of timings or a couple of distributions into our simulation just to show how they work. So for example, at our start point, maybe we only start processing a piece of work every 25 minutes. The bodywork activity, we might speak to our process owners and they might tell us that it takes between 10 and 20 minutes. So let's go for a uniform distribution. At assembly, we might be told that it takes on average an hour. And again, we want to remember the time units that we're working in. So an hour is of course 60 minutes. So we input our 60. At inspection 1, we've maybe spoken to the guys and or we've done our little triangular distribution. And we've asked them what their best case situation is. And they've maybe come back to us and said 300 seconds. We can simply change that or convert that within the parameter by entering a simple formula here. So 300 divided by 60 will give us our time in minutes. Again, the upper range, let's say it was 480, we can divide that by 60. And let's say the most common occurrence is 360 seconds. We can divide that by 60. At the paint activity, let's say that takes on average 25 minutes. And inspection 2 maybe takes between 5 and 10 minutes. So let's go for a uniform. Change that to 5 to 10. And the shipping activity maybe takes 15 minutes. And sanding might take us 2 hours. We could of course put 2 times 60. I'm feeling confident in my math, so I'm going to say 120 minutes. So this is essentially how we add the timings to our simulation. We now want to reset our model and we want to run. I run this at full speed because I'm only interested in the results at the moment. And at this point, I would want to validate these numbers with the process owners. So I'd be asking if their factory over 2 weeks, if they produce around 85 cars. If they do, then we're in a good position and we can start to actually experiment with the model. If the numbers feel right, we can identify a bottleneck here, for example, at assembly 1. There's this big queue of work items forming before assembly. If I click on the queue and click on the current contents, we can identify that this is in fact a true bottleneck because the contents of the queue is continually increasing. So this is a really easy, quick and easy way of identifying if this is a true bottleneck. If I click on Assembly 1 and click on the Results tab, I can view the individual results for this activity. You can see that this activity has an incredibly high utilization, i.e. it's working over 99% of the time. So this looks like a real kind of problem area for us within our manufacturing line. We can then, because we've compared the numbers with real life and they seem okay, we can then start experimenting with our model and testing what improvements or what benefits we might get by adding a second assembly line, for example. So maybe the purpose of this simulation was to justify whether or not adding a second assembly line is worth it. What I can do is I can hold down my control key and click on assembly and just drag this down, and that will copy that object. So we've effectively added our second assembly line. By copying the object in that way, it copies all of the properties of the object. So you can see that the timing for assembly 2 is also 60 minutes. At the moment, with a single assembly line, we produced 85 cars. If I reset the model and run, this time with the second assembly line, you can see that first of all, we've reduced our bottleneck quite substantially, which we would expect, and we've also produced 164 cars. So this is quite a substantial increase, and we can use that potentially to justify any decisions on whether or not we actually add that second assembly line. So I mentioned that we have variability within our simulation. If we produce 164 cars for this run, we don't know if that's a good day or a bad day. If I reset and run the simulation with new random numbers, we're still using the same distributions. It's just we're rolling the dice at a different time, or I'm getting a different result. And you can see when I rerun the simulation, we've in fact produced 162 cars this time. If I run it again, we've jumped back up to 172. So there's a lot of variation here within our simulation. And if our bosses want to know how many cars we're likely to produce with this manufacturing line, we don't want to just stake our claim on just a single run, because we've seen already that we've had runs of 168, or in this example 172. It might not seem a lot, but if we're producing private jets, that's obviously a fairly dramatic effect on our bottom line and our company's profits. So we want to be able to run as many runs as we need to in order to have a statistically justified decision. So if I click on the endpoint and click on results, you can see that we have this work completed result. If I right click on the work completed result, we add that result to what we call the result summary. If I click on the Home tab and click on my Results Manager, you can see that that result has been added here. I can add results from all across my simulation, so every single object, I can take key performance indicators from each of those objects, right-click on the result that I want to see, and they will all be added to this Results Manager. I can then export or convert to PDF, I can print it, and this is a really nice quick way of creating a little report for your management to detail key performance indicators. If we're looking to produce a bit more of a bespoke result, we'll talk through how to do that in our fourth webinar. So at the moment, we have a single result, which is 172, which matches the endpoint. If I click on OK here, and I want to run multiple trials, or multiple runs, so that we can take into account good days and bad days and get a bit more of a representative figure for the capability of this system. If I click on the lower portion of the Run Trial button and click on Trial Setup, I'm just going to run 100 runs. I'm just choosing a random number, and I'm going to click on Apply. If I click on the top portion here, that's going to start running my trial, and as you can see, we're processing those 100 runs extremely quickly. Once those 100 runs have been completed, the Results Manager opens up, and this time, instead of a single result, we have what we call a confidence interval. I'm not going to go into too much detail in terms of our confidence interval, but essentially what we're saying here is that we are going to be producing between 161 cars and let's say 166 cars with an average of 163 cars. We're using what's called a 95% confidence interval. That basically means that if we were to look at this over the course of 100 days, 95% of our days would fall into this range. So that is essentially how we can start to use Simulate to start to justify making some of our decisions. We built this model in a little over half an hour, and you can already see how we can start to experiment by adding second assembly lines, for example, to start justifying whether or not the investment in that assembly line is worth it. We can also start to see how capable this system is. So how many cars are we likely to produce over the course of a 2-week period? We're really coming towards the end of the demonstration, but I'd like to open the floor for you guys to ask any questions which you might have.
Sure, so thanks, Max. That was really interesting to see how quickly you can build up a simulation and get those sort of results. So we do have some questions that were sent through as you were building up your simulation. The first one being, can Simulate link to Excel, and what sort of data can you bring into your simulations?
Cool. So that's a really good question. Simulate can link to Excel really easily. So, for example, if I click on my Data and Rules tab here, and I can click on this feature, which is Excel Connections. And we'll cover Excel Connections as part of our third topic. But basically, Excel Connections allow us to easily import data from an Excel spreadsheet into Simulate. We store the information on an internal spreadsheet within Simulate, and we can reference it from anywhere within the model. It also brings me to an interesting point. If we've conducted a time and motion study, and we've got a whole bunch of data points, and we're not sure which distribution we might want to use, we can actually click on the Advanced tab here, and using this feature called StatFit, we can actually paste the information directly from Excel into StatFit, and that will tell us the best distribution to use to match our data. Hopefully that answered your question.
Great, and I guess going on from that, another question about distributions. And what is the relationship between the average distribution and a normal distribution? And I suppose when would you use either of those types when building up your simulations?
Cool. So again, a good question. An average distribution is essentially a normal distribution, but the standard deviation is 25% of the mean. So if I was to change my assembly activity here to a normal distribution, the standard deviation is by default 25% because it was set up as an average. So a normal distribution just gives us a little bit more room to play around with because we can control the standard deviation, but the average is the same as a normal distribution, but the standard deviation is 25%.
Excellent. So I hope that's answered the user's question. So another one in regards to your work items and the flow of work through the simulation. Is it possible to simulate the processing of more than one kind of unit through your simulation?
So if I understand the question, I think we're looking at adding different product types within our simulation. That's absolutely possible. We're going to be covering that in quite a lot of detail in our next session. But essentially, is a feature called labels. And labels allow us to store a piece of information on the work item itself. So we might stamp each work item with a product type. Let's say we've got 3 product types within our simulation. Each work item will get stamped with its product type, so it will be either a 1, 2, or a 3. And then we can control for example, the routing through the simulation by using, if I click on routing out, we can use the label-based routing to control where those specific products go.
Excellent. So sort of adding on to that in a separate question. So I mean, this example was using cars. So could this consider 20 different types of cars? And each of those different product types have different operation cycle times. And is it possible to then have, you know, certain work item types, you know, perhaps bypass some of your activities, or, you know, certain work items are going, you know, down different lines?
Yeah, for sure. So for that type of setup, which is a little bit more complex, we probably want to store the information within a spreadsheet. I'll give you a really quick demonstration. We're just going to, let's say, assume that for a certain activity, product type 1 or car type 1 is going to take 10 minutes, car type 2 is going to take 20, and car type 3 is going to take 30 minutes. At assembly 1, I would want to click on the activity, and I can click on these 3 little dots here, and that's going to help me build up a formula for how to identify the timing for that activity. So my information is stored in a spreadsheet, so I would select my spreadsheet, and I know that the information is stored in column 1. The row, however, is going to be dependent on the product type. If it was a product type 1, that's going to be stored in a label called product, which we've not yet created. But essentially, when that work item reaches assembly, we're going to look at the value contained within that label, and that's going to reference the appropriate row for us. Again, we'll go into this type of thing in session 4 in the full detail.
Great. So I hope that's answered that. So going on to another object here that someone's asked about, can you model conveyors easily within Simulate?
We can. It's a good question. Within Simulate Professional and Simulate Professional Plus, we have the Advanced Building Blocks section. And within that section, we have conveyors. I'm just going to add a conveyor on screen, just in the same way as we would with any other object. And you can see that the conveyor is, we can change the length of the conveyor, for example, and we can also control the speed of the conveyor. In addition to that, if you have Simulate 2015, I believe, or later, we can actually create what's known as fixed pitch or power and free conveyors. So we've got a lot more functionality around that, where we can actually have hanging work items which are controlled on the conveyor as well. We just connect them in the same way as we would any other Simulate object. Let's just quickly connect that on screen. If I reset my simulation and slow things down, let's make sure that we're actually routing to the conveyor. That would probably help. So if I reset and run, you can see that the work items are arriving on the conveyor. We're getting different sized gaps between the two because of the variation from our start point. But you can see that each of the work items moves along the conveyor into the queue.
Excellent. Well, thanks for demonstrating that object. Another user has asked, can we model a job shop type of manufacturing layout using Simulate?
We can. The jobs matrix feature allows us to model that type of setup. So for those users who are not aware, a job shop is the setup where we have multiple machines within our simulation, and different product types will move through those different machines in different orders. In those setups, we don't really want to be setting up a massive tangled web of routing arrows and complex control structures. So what we can use is a feature called the jobs matrix. The jobs matrix will probably take me more than 8 minutes to go through, but there's a lot of useful information on the jobs matrix within our help files. Essentially, we build separate areas within our simulation. So without ruining my my initial simulation, we have lots of different machines within our simulation. And let's say this is machine 1. And this is machine 2. We're just going to keep things really simple and just have 2 machines. But equally, we could have 200 machines or 2,000 machines. We use the routing out feature on machine 1, and we change that to jobs matrix. Once we've set up the jobs matrix, what Simulate will do is look at what product type is currently in the machine, which is stored on a label. It will also look at what step within that product that part is at. So if that particular work item is on its 5th step, it will look at the jobs matrix to see what the 6th step is, and it will then divert it to the appropriate machine. But it takes a little bit more time to set up, and I don't want to get kind of halfway through it before the end of the webinar. But there's a lot of useful information on jobs matrices within the support file.
Sure. So yeah, if you can just go to simulate.com/help and search for the jobs matrix feature, you should find some further examples on what Max had just brought up there. So another question that has come in, is there a way that I can see results of different scenarios side by side?
There is. So we've done a couple of runs within the simulation, but because we've added those extra features, let me just change things back to the way that they were. And let's reset our simulation, and we'll run. We're only interested in the results, so I'm going to speed this all the way up to the end. So we've performed our first run. If I click on my results manager and click on KPI history, you can see that we have a base run of 85 work items completed. If I then add my second assembly line by holding down my control key, clicking and dragging, if I reset my simulation and run, if I click back in to the KPI history, you can see that we can compare the base run of 85 versus our current run of 168. So it's a really quick way of just viewing multiple runs next to each other. We can again print that information and export it to Excel. Whilst I'm in the results manager here, it's also worthwhile clicking on the All Object Results tab, and that actually displays all of the individual results for all of our objects within our simulation. So this is a really quick way of getting an overview of all of the results and all of the important information within our simulation, all in one place. Again, we can easily print that and start forming reports.
That's great. I think we have time for maybe one more question here, and someone has asked, in terms of your input parameters, are there any features that you can use in your simulation to make it a bit more accessible, perhaps to an end user if you're passing the simulation on to someone else? So in terms of creating a sort of user interface?
Yeah, for sure. So for example, if I click on the Insert tab here, we're able to insert buttons on screen. let's create a new button. We really want that button to perform a task, and that task is generally linked to a feature called Visual Logic. If I don't really want to go into Visual Logic just now, but we can start looking at this in our fourth webinar. We may use the button to open up a spreadsheet, in which case we just have a single line of Visual Logic, which is display sheet, and then we specify which spreadsheet we want to display. Once we've added that button on screen, whenever a user clicks on it, that spreadsheet will be displayed. By using the spreadsheet, that gives them a familiar environment to be able to input their parameters, and that will automatically link into the simulation. We can also link Excel to Simulate really easily, as we've seen. So what we often do as consultants is have our entire user interface within the Excel environment, and people can tailor their inputs there.
Great. Well, thanks for that, Max, and thanks everyone for attending and for asking those questions. So that's all we have time for now. So sorry if we didn't manage to answer everyone's questions, but for anyone that has submitted something that we haven't gotten to, we'll be in touch soon to answer those for you. And thanks everyone for attending today's webinar. The next webinar that Max is hosting is in 2 weeks' time on Tuesday, September 27th, where Max will show you how to add a bit more simulations, and again, this one will be posted on our website soon, and we will send you an email as soon as it is available. So until then, we'll see you soon on September 27th. Thank you.